What is CSS and what is its role on the web? CSS, which stands for Cascading Style Sheets, is a crucial component of modern web development. It's a markup language used to apply styles for HTML. In simpler terms, if HTML is the structure of a web page, CSS is what makes it look good. The primary role of CSS is to separate the content of a web page from its visual presentation. This separation allows web developers to create more flexible and maintainable websites. With CSS, you can control the layout, colors, fonts, and overall visual appearance of web pages without altering the HTML structure. Let's consider a simple analogy. If you think of a website as a house, HTML would be the foundation and framework, while CSS would be the paint, wallpaper, and decorations that make the house visually appealing and unique. CSS works by selecting HTML elements and applying styles to them. These styles can include properties like color, font size, and many more. By changing these properties, you can dramatically alter how a web page looks without changing its content. One of the most powerful aspects of CSS is its ability to create responsive designs. This means that with CSS, you can make your website look great on any device, whether it's a desktop computer, a tablet, or a smartphone. CSS allows you to adjust layouts, font sizes, and other visual elements based on the screen size of the device viewing the website. Another important feature of CSS is its cascading nature, which is where the cascading in its name comes from. This means that styles can be inherited and overridden, allowing for a hierarchical structure of styling. You will learn more about how the cascade works in future videos. CSS also supports the use of external style sheets. This means you can keep all your styling rules in a separate file, which can then be linked to multiple HTML pages. This feature greatly enhances the maintainability of websites, especially larger ones. Instead of having to change styles on each individual page, you can make changes in one CSS file that will affect all linked pages. In the world of web development, CSS plays a vital role in creating visually appealing, responsive, and user-friendly websites. It allows developers to transform simple HTML documents into engaging web experiences that capture users' attention and enhance their interaction with web content. What is the basic anatomy of a CSS rule? CSS is responsible for the styles of a web page. All of these styles are made up of various CSS rules. A CSS rule is made up of two main parts, a selector and a declaration block. Let's take a look at the basic syntax. A selector is a pattern used in CSS to identify and target specific HTML elements for styling. Examples of selectors include type selectors, class selectors, and ID selectors. The curly braces in the example are known as a declaration block. A declaration block applies a set of styles for a given selector or selectors. Inside the declaration block, you will have a series of declarations. Each declaration consists of a property and a value. The property is the CSS identifier that specifies which feature is being styled. An example of a property would be the background color property. The value would be the specific setting applied to that property. For example, if the property is background color, a value could be purple, which sets the background color to purple. After each property name, you need to place a colon, and after each value, you should have a semicolon. Now that you know the syntax for a CSS rule, let's take a look at an example. In the CSS rule, a type selector targets all paragraph elements on the page. Inside the declaration block, there is one declaration. The declaration consists of the color property with a value set to blue. This will change the text color for all paragraph elements to blue. If you want to apply the same set of styles to multiple selectors, you can create a selector list with each selector separated by a comma. Here is an example of styling multiple selectors. In this selector list, there is an ID selector targeting all the HTML elements with the ID value of title. All the ID selectors must start with a hash symbol. Then there is a comma followed by a class selector that targets all HTML elements with the class value of subheading. All class selectors must start with a dot. The entire selector list will receive the same styling, with the text color set to navy. What is the Meta Viewport Element used for? The Meta Viewport Element is a crucial component in responsive web design. It's a special HTML meta element that gives the browser instructions on how to control the page's dimensions and scaling on different devices, particularly on mobile phones and tablets. Let's take a look at the basic syntax of the Meta Viewport Element. This element is typically placed in the head section of your HTML document. But what does each part of the element mean? Let's see. The width device width part tells the browser to set the width of the page to match the screen width of the device. This is essential for creating responsive layouts that adapt to different screen sizes. The initial scale 1.0 sets the initial zoom level when the page is first loaded, A value of 1.0 means that the page is displayed at 100% zoom without any scaling. By using the Meta Viewport element, you're ensuring that your web pages are displayed properly on mobile devices. Without it, mobile browsers will typically render the page at a desktop screen width and then scale it down, which can result in a poor user experience with tiny and hard-to-read text. The Meta Viewport element also allows you to control whether users can zoom in and out of your web pages. While it's possible to disable zooming with the user scalable no attribute, it's generally recommended to avoid this for accessibility reasons. Many users rely on the ability to zoom for better readability, especially those with visual impairments. Here is an example of what not to do. Instead, it's better to design your website to be responsive and readable at different zoom levels, ensuring that all users can comfortably access your content. The Meta Viewport element plays a crucial role in creating mobile-friendly websites. It ensures that your carefully crafted, responsive websites are displayed as intended on various devices, providing a better user experience for all visitors to your site. What are some default browser styles applied to HTML? When you start working with HTML and CSS, you'll notice that some styles are applied to your web pages, even before you write any CSS. These styles are called default browser styles, or user agent styles. These default browser styles provide basic formatting to ensure that HTML elements are displayed in a readable way across all browsers. However, these styles can vary slightly from one browser to another, which is why it's important to understand them when designing a consistent look for your website. Let's take a look at some of the common default browser styles applied to various HTML elements. Headings are one of the most commonly used HTML elements and are styled by default to have varying sizes and weights. For example, H1, the highest level heading, is usually bold and larger in font size compared to lower level headings like H2, H3, and so on. These heading tags help define the hierarchy and structure of your content. Here's what the example looks like rendered on the page. Another element with default styles is the HR element, which creates a horizontal rule often used to visually separate sections of content. Browsers generally apply a simple line style to this element. To understand it better, let's look at this code example. The horizontal rule appears as a thin line with spacing above and below the text to distinguish between sections of content. Here is what the example looks like when rendered on the page. Next, we will look at the block quote element. Block quotes are used to indicate a section of text that is a quotation from another source. Browsers typically add indentation and sometimes italicize the text. The indentation helps set block quotes apart from the rest of the text, making it clear that this content is quoted from another source. Let's take a look at this code example. The block quote element will produce an indent on the text, applied by the default browser styles. Here's what the example looks like in the browser. Another element with default styles is the anchor element A, which is styled with a default blue color and underlining to make it recognizable as a link. Let's take a look at the following HTML example. The following code has 4 paragraph elements with an anchor element in the middle. The anchor element is styled in blue with an underline to show users to go to the free Codecamp Learn page. Here's what the output looks like rendered on the screen. Finally, we'll look at the unordered and ordered list elements. Browsers add basic formatting to lists, including indentation and bullets or numbers, depending on whether you're using an unordered list UL or an ordered list OL. In this code example, we are using an unordered list and an ordered list. Both of these lists will be slightly indented to the right by default. Here is what the output will look like on the screen. For all of these examples, you saw how the browser applied default spacing, varying font sizes and weights to these HTML elements. In later lecture videos, you will learn how to reset some of these default styles using a CSS reset. What are inline, internal, and external CSS, and when should you use each one? CSS can be applied to a web page in 3 main ways: inline, internal, or external. Each method has its own use case, advantages, and limitations, and knowing when to use each one is essential for writing clean, efficient, and maintainable code. Let's break down the 3 types of CSS and when you should use them. Inline CSS is written directly within an HTML element using the style attribute. It applies styles to a specific element. Here is an example using inline CSS. In this example, we are using the style attribute to set the paragraph text to red. Here is what the example looks like rendered on the page. Inline CSS is generally used for quick, one-off styles or to override other styles for a specific element. However, it should be avoided in most cases because it can clutter the HTML and make the code harder to maintain. Most of the time, it's better to use internal or external CSS. Internal CSS is written within the style tags inside the head section of an HTML document. It applies styles to the entire page and is useful when you need to style a single document. Here is an example of internal CSS. In this example, the internal CSS applies blue text to all P elements on the page. You can see the result on the screen. Internal CSS is best used when you need to apply styles to a specific page rather than across multiple pages. It's useful for single-page websites or when the styles don't need to be reused elsewhere. However, there are some downsides, such as not promoting reusability across multiple pages. Additionally, like inline CSS, it mixes HTML and CSS, making the code harder to maintain in larger projects. External CSS is written in a separate CSS file and linked to the HTML document using the link element in the head section. It allows you to style multiple pages consistently and is a preferred method in professional web development. Here is the HTML part of our code example. In an earlier lecture video, you learned that the link element has a rel attribute that specifies the relationship between the current document and the linked resource. On the other hand, the href attribute specifies the URL of the linked resource, indicating where the resource should be retrieved from. Here is the CSS of this example in a separate file named style.css. This example targets all paragraph elements on the page and sets the text color to green. Here is what the example looks like rendered on the page. External CSS is ideal for large projects where you want to maintain a consistent style across multiple pages. It promotes separation of concerns by having HTML handle the structure and CSS handle the styling, which makes the code more maintainable and scalable. Understanding when to use each type of CSS is crucial for efficient and effective web development. In most cases, external CSS should be your go-to approach, especially for larger and more complex projects. How do width and height work? In CSS, the width and height properties are used to control the dimensions of elements on a web page. These properties can be defined in different units, such as pixels, percentages, viewport units, and more. You will learn more about these types of units in future videos. The width property specifies the width of an element. If you do not specify a width, then the default is set to auto. This means the element will take up the full width of its parent container. The height property specifies the height of an element. Similarly, the height is auto by default, which means it will adjust to the content inside. Here is an example using the width and height properties. In this example, we have a div element with a class named box. This element will be occupying 100 pixels in height and width, whereas the background color will be sky blue. Pixels are a fixed size unit of measurement in CSS, providing precise control over dimensions. You will learn more about those in later videos. Here is the output result on the screen. The min width property specifies the minimum width an element can take. Even if the content inside it is smaller, the element won't shrink below this value. The min height specifies the minimum height an element can take. It ensures that the element does not become shorter than the set value. Here is an example. This example demonstrates how min width and min height work. Even though the box has a width and height set to 50 pixels, it will actually be 100 pixels by 100 pixels. This is because the min width and min height are set to 100 pixels, which are larger than the specified width and height. Remember, if min width or min height are larger than the width or height, they will override the smaller values. This ensures that elements don't become too small, which is important for maintaining a consistent and usable design. Here's what the result will look like displayed on the screen. The max width specifies the maximum width an element can grow to, even if there is enough space for it to be wider. The max height specifies the maximum height an element can grow to, regardless of the content size. Here is an example. This example demonstrates how max width and max height override width and height. Even though the box is set to 200 pixels by 200 pixels, it will actually be 150 pixels by 150 pixels. This is because the max width and max height are set to 150 pixels, which is smaller. Remember, when max width or max height are smaller than width or height, they take precedence. This is important for controlling the maximum size of elements in your layout. Here's what the result will look like displayed on the screen. CSS prioritizes min width and min height over width and height. Max width and max height restrict dimensions if values exceed their limits. For example, if you set the width to 600 pixels and max width to 500 pixels, the element will be limited to 500 pixels wide. The max width overrides the wider setting, keeping the element within the specified maximum size. This ensures elements stay within the desired size ranges, regardless of standard width and height values. What are the different types of CSS combinators? CSS combinators are used to define the relationship between selectors in CSS. They help in selecting elements based on their relationship to other elements, which allows for more precise and efficient styling. We will discuss some primary CSS combinators and their use cases, starting with the descendant combinator. A descendant combinator is used to target elements matched by the second selector if they are nested within an ancestor element that matches the first selector. An ancestor can be a parent element or a parent's parent. Let's take a look at an example. In this example, we use the descendant combinator to select all image elements inside figure elements and apply a solid black border on all four sides. Note that a space is used between the parent and the child selector. In this case, the figure would be the parent and the image would be the child. Here's what the example looks like rendered on the page. If you had multiple images inside a figure element, using the descendant combinator would be a good way to apply a solid black border around each of those images. Another type of combinator would be the child combinator. The child combinator in CSS is used to select elements that are direct children of a specified parent element. This combinator targets only elements with a specific parent, making your CSS rules more precise and preventing unintended styling of deeper nested elements. Let's take a look at the following HTML example. In this HTML structure, the container class is applied to a div element. Inside this container, there is a direct child, P element, first, followed by two additional div elements, each containing a p element, second, and third. The first p element is a direct child of the container element, while the other two p elements are nested inside another div element, making them deeper descendants. Here is what the example currently looks like without any CSS. To apply styles to just the direct child of the container class, you can use the child combinator like this. In this example, we are only targeting the direct child of the container class. This will give the direct child the text color of blue. Here is what the example looks like rendered on the page. Because the other two paragraph elements are nested inside div elements, they are not considered direct children of the container class and will not get the text color of blue. Another common combinator would be the next sibling combinator. The next sibling combinator in CSS selects an element that immediately follows a specified sibling element. This combinator is useful when you want to apply styles to an element that directly follows another element, allowing for targeted styling based on the element's position relative to its siblings. Let's take a look at the following HTML example. Here we have a figure element containing an image element, followed by a fig caption element. The fig caption element is the immediate sibling of the image element. If you wanted to apply a black border around the fig caption element, you can use the next sibling combinator like this. In this example, the next sibling combinator selects the fig caption element that immediately follows the image element. The applied CSS rule adds a 4-pixel solid black border around the fig caption. Here is what the example looks like rendered on the page. Another common combinator is the subsequent sibling combinator. The subsequent sibling combinator in CSS selects all siblings of a specified element that come after it. Unlike the next sibling combinator, which targets only the immediately following sibling, the subsequent sibling combinator can target any siblings that follow the specified element, offering greater flexibility in styling. Let's take a look at the following HTML example. In this HTML structure, we have an H2 element followed by 4 paragraph elements. The paragraph elements are siblings of the H2 element. If you want to style all of the paragraph elements that come after the H2 element, then you can use the subsequent sibling combinator, like this. In this example, all paragraph elements following the H2 element will have the text color green. The subsequent sibling combinator targets all paragraph siblings that appear after the H2 element, regardless of whether they are immediate siblings. Here's what the example looks like rendered on the page. In conclusion, understanding and using various CSS combinators allows you to apply precise styles to your HTML elements, enhancing the control and flexibility of your design. By mastering these selectors, you can create more sophisticated and targeted styling rules that improve both the appearance and functionality of your web pages. What is the difference between inline and block level elements in CSS? In HTML and CSS, elements are classified as either inline elements or block level elements, and this classification dictates how they behave in the document layout. Understanding this difference is crucial for controlling how your content is displayed on a web page. Block level elements are elements that take up the full width available to them by default, stretching across the width of their container. These elements always start on a new line and push other content to the next line, creating a block of content. Block level elements have the CSS property display block applied by default. This property ensures that the element stretches to fill the container's width and appears on a new line. Some common block level elements are div elements, paragraphs, headings, ordered lists, unordered lists, and section elements. Here is a code example of a block level element. In this example, we have two paragraph elements where the first one has a red border around it. Here is what the result looks like rendered on the page. The two paragraph elements do not share the same line because they are block elements by default. So, both paragraph elements will take up the full width of their container, which in this case is the body element. Block level elements are ideal when you want content to stack vertically, such as paragraphs, sections, or larger blocks of content. They're commonly used to define the layout and structure of a web page. Inline elements, unlike block level elements, only take up as much width as they need and do not start on a new line. These elements flow within the content, allowing text and other inline elements to appear alongside them. Inline elements have the CSS property display inline applied by default. This property ensures that the elements remain within the flow of the content and does not break onto a new line. Common inline elements are span, anchor, and image elements. In this example, we have a span element nested inside of a paragraph element. The span element has a red text color with a green border around it, so you can see the highlighted word better. Here's the output of the code on the screen. As you can see, the span element only takes up as much space as the word red and does not push the following content to a new line. Inline elements are best used for styling smaller portions of text or content within a line, such as emphasizing a word, creating hyperlinks, or applying specific styles to parts of a paragraph. How does inline block work and how does it differ from inline and block elements? When working with CSS, you often encounter three different types of display behaviors for elements: inline, block, and inline block. Each one of these properties affects how elements are positioned and how they interact with other elements on the page. In this lecture, we will focus on how the inline block property works and how it differs from both inline and block level elements. Block level elements behave like large containers or blocks that take up the full width of their parent container. They always start on a new line, and their height and width can be adjusted. Inline elements only take up as much space as they need. They flow within the surrounding content and do not break onto a new line. The inline block property is a hybrid of these two behaviors. Like inline elements, inline block elements remain in the text flow without starting on a new line. However, unlike inline elements, you can adjust the width and height of an inline block element, just as you would with block level elements. In short, the key difference between inline and inline block is that inline elements cannot have their size controlled, whereas inline block elements allow for full control over dimensions while still staying in line with other content. Let's take a look at an example. Here we have a div with a class of container. Inside that div element, we have two span elements. Here is the accompanying CSS. Each one of the span elements is set to display inline block and has a width and height set as well. Here is the output on the screen. The inline block elements will appear side by side because they behave like inline elements, but they also have a specified width and height, which gives them block-like properties. But if you remove the inline block elements will appear side by side because they behave like inline. Display inline block property, neither the height nor the width will be applied, even though you define them clearly. In this code, we removed the display inline block property, but kept everything else intact. Here, the span elements revert to their default behavior as inline elements. As a result, the specified width and height are ignored, and the elements only take up the space needed for their content. Understanding how inline block works is useful because you can use it for creating layouts that require both alignment and dimension control within a continuous text flow. What are margins and padding, and how do they work? Margin and padding are essential properties in CSS for creating well-structured, readable web pages. Margins control the space outside an element, helping to separate it from other elements and define the layout structure, while padding controls the space inside an element, improving content readability and aesthetic appeal. Let's take a look at the following illustration. In the illustration, we have a black dotted border around the content. The content, in this case, is the FreeCodeCamp logo. The dark blue color represents the padding, which is used to apply space inside the element, between the content and its border. The light blue color outside the black dotted border represents the margin. The margin is the space applied to the outside of the HTML element. Let's take a look at some examples. Here is an HTML example of 3 paragraph elements on the page. To apply spacing to the top of each paragraph element, you can use the margin top property, like this. In this example, we are applying 20 pixels of margin only to the top of each paragraph element. We also have a solid black border on all 4 sides, so you can see the margin better. Here is what the example looks like rendered on the page. The 4 different margin properties are margin top, margin right, margin bottom, and margin left. Here is an example of using all 4 properties. In this example, we are assigning spacing values on all 4 sides of the paragraph element. A solid black border has also been added, so you can see the margins better. Here's what the example looks like rendered on the page. Another way to use the margin property is with shorthand notation. You can specify 1, 2, 3, or 4 values at once. Let's explore these options together. When using a singular value on the margin shorthand, that exact value will be applied to all 4 sides of the target element. Here is an example of using a single value on the margin shorthand. This code example will apply 10 pixels of margin equally to all 4 sides of the paragraph element. When using 2 values, the first value applies to the top and bottom, while the second value applies to the left and right sides of the element. Here is an example of using 2 values for the margin shorthand. This sets the top and bottom margins to 10 pixels and 20 pixels for the left and right margins for the paragraph element. If 3 values are provided, the first value applies to the top margin, the second value applies to the left and right margins, and the third value to the bottom margin. This sets the margin to 10 pixels for the top, 20 pixels for the left and right, and 30 pixels for the bottom. When using 4 values, this gives you more control, as you can independently specify each margin value for each side of the target element. The first value targets the top, the second value targets the right, the third value targets the bottom, and the fourth value targets the left. Here is an example of using the margin shorthand with 4 values. This sets the margin to 10 pixels for the top, 20 pixels for the right, 30 pixels for the bottom, and 40 pixels for the left. The padding property is used to apply space inside the element, between the content and its border. Like the margin property, the 4 padding properties are padding top, padding right, padding bottom, and padding left. Here is an example on how to set the padding for a paragraph element. This sets the padding to 10 pixels for the top, 20 pixels for the right, 30 pixels for the bottom, and 40 pixels for the left. Here is what the example looks like rendered on the page. As you can see, the padding is applied to the content which is inside the border, unlike margin, which applies to the outside of the border. Just like the margin property, you can also choose to use the shorthand for the padding property. You can either specify 1, 2, 3, or 4 values on the padding shorthand property as well. Here is an example of using the shorthand for the paragraph element from earlier. In the example, using the shorthand, the code will set the padding to 10 pixels for the top, 20 pixels for the right, 30 pixels for the bottom, and 40 pixels for the left of the paragraph element. Here is what the example looks like rendered on the page. What is CSS specificity? And the specificity for inline, internal, and external CSS? CSS specificity is a fundamental concept that determines which styles are applied to an element when multiple rules could apply. Understanding specificity helps developers resolve conflicts between different CSS rules and ensures that the desired styles are consistently applied. CSS specificity is calculated based on the type of selectors used. The highest specificity is attributed to inline styles, which are applied directly to an element through the style attribute. Following this, ID selectors, like main and header, have a higher level of specificity. Next, class selectors, attribute selectors, and pseudo-classes come into play. Examples include class selectors such as container and button, attribute selectors like type text, and pseudo-classes such as hover. These have a moderate level of specificity. Type selectors such as div and h1 and pseudo-elements like before and after have a lower specificity compared to the previous groups. Finally, the universal selector such as div and pseudo-class. Examples include class selectors such as container and button, attribute selectors like type text, and pseudo-classes such as hover. These have a moderate level of specificity. Type selectors such as div and h1 and pseudo-elements like before and after have a lower specificity compared to the previous groups. Finally, the universal selector, represented by an asterisk, has the lowest specificity of all. Specificity values are calculated as a four-part value, A, B, C, D. A, inline styles, 1 or 0. B, number of ID selectors. C, number of class selectors, attribute selectors, and pseudo-classes. D, number of type selectors, pseudo-elements, and universal selectors. Each part of the specificity value carries different weight. Inline styles, A, have the highest weight, contributing a value of 1 to the first part of the specificity value. ID selectors, B, carry the next highest weight, with each ID contributing 1 to the second part of the specificity value. Class selectors, attribute selectors, and pseudo-classes, C, carry moderate weight, with each contributing 1 to the third part of the specificity value. Type selectors and pseudo-elements, D, have the lowest weight, with each contributing 1 to the fourth part of the specificity value. The universal selector contributes 0 to the specificity calculation and does not affect specificity. Its inclusion in a selector does not change the specificity value. Inline CSS has the highest specificity because it is applied directly to the element. It overrides any internal or external CSS. The specificity value for inline styles is 1000. Here is an example using inline styles for a div element. In this example, the text will always be red, regardless of any other styles applied via internal or external CSS. Internal CSS is defined within a style element in the head section of the HTML document. It has lower specificity than inline styles, but can override external styles. The specificity value for internal styles is determined by the selectors used. For example, an ID selector within internal CSS has a specificity value of 0100. In this example, the text will be blue unless an inline style or a more specific external style is applied. External CSS is linked via a link element in the head section and is written in separate CSS files. It has the lowest specificity but provides the best maintainability for larger projects. The specificity value for external styles is also determined by the selectors used. For example, a class selector within external CSS has a specificity value of 0010. In this example, the text color is defined in the styles.css file, and will be applied unless overridden by internal or inline styles. What is the asterisk selector and what is its specificity? The universal selector is a special type of CSS selector that matches any element in the document. It is often used to apply a style to all elements on the page, which can be useful for resetting or normalizing styles across different browsers. The universal selector can be used to select all elements within a specific context or globally across the entire document. Here is an example of using the universal selector for setting the margin and padding for the entire HTML document. In this code example, the universal selector resets the margin and padding of all elements to 0, which is a common technique used in CSS resets. The universal selector has the lowest specificity value of any selector. It contributes 0 to all parts of the specificity value, 0, 0, 0, 0. This means that any other selector, including type selectors, class selectors, ID selectors, and inline styles, will override the styles set by the universal selector. Let's take a look at the following HTML and CSS example. The universal selector sets the text color to blue for all elements. However, the P type selector overrides this by setting the text color to red, specifically for P elements. If an element has the highlight class, the class selector takes precedence, changing the text color to green. Finally, the unique ID selector, which has the highest specificity, will override all others, setting the text color to purple. What is the specificity for type selectors? Type selectors, also known as element selectors, target elements based on their tag name. These selectors are fundamental in CSS and allow you to apply styles to all instances of a specific HTML element. Type selectors are straightforward to use and are written simply as the tag name of the element you want to style. Here is an example of a type selector targeting all paragraph elements on the page. In this example, all P elements will have their text color set to blue. Type selectors have a relatively low specificity compared to other selectors. The specificity value for a type selector is 0001. This means that type selectors will be overridden by class selectors, ID selectors, and inline styles, but can still apply styles unless those higher specificity rules are present. Let's take a look at an example where the class selectors will override the styles of the type selector. Both paragraph elements have a class called para. Inside the CSS file, the type selector targets paragraphs, and the class selector targets the elements with the para class. All paragraphs on the page with the class of para will have the text color set to red instead of blue, because class selectors have a higher specificity than type selectors. What is the specificity for class selectors? Class selectors are a key part of CSS, allowing developers to target multiple elements with the same class attribute and apply consistent style. This makes them highly versatile and efficient for applying styles across a website. Class selectors are defined by a period, followed by the class name. They can be applied to any element in the HTML document. Here is an example using a class selector. In this example, any element with the class highlight will have its text color set to green. Class selectors have a higher specificity than type selectors, but lower than ID selectors and inline styles. The specificity value for a class selector is 0010. This means that class selectors can override type selectors, but they can be overridden by ID selectors and inline styles. Class selectors can be combined with other selectors to create more specific rules. Here is an example combining a paragraph type selector with a class selector. This rule applies only to P elements that also have the highlight class, making their text bold. What is the specificity for ID selectors? ID selectors are among the most powerful selectors in CSS, allowing developers to apply styles to specific elements with unique identifiers. This makes them highly effective for targeting individual elements that need unique styling. ID selectors are defined by a hash symbol, followed by the ID name. They should be unique within an HTML document, meaning no two elements should share the same ID. Here is an example using an ID selector. In this example, the element with the ID unique will have its text color set to purple. ID selectors have a very high specificity, higher than type selectors and class selectors, but lower than inline styles. The specificity value for an ID selector is 0100. This means that ID selectors can override class selectors and type selectors, but can be overridden by inline styles. ID selectors can be combined with other selectors to create even more specific rules. Here is an example of combining a div type selector with an ID selector called unique. This rule applies only to div elements that have the unique ID, setting their font size to 20 pixels. What is the exclamation mark important keyword and what are the best practices for using it? The exclamation mark important keyword in CSS is used to give a style rule the highest priority, allowing it to override any other declarations for a property. When used, it forces the browser to apply the specified style, regardless of the specificity of other selectors. Let's say you have an HTML paragraph element with inline styles, like this. In this example, the paragraph element has a background color set to light blue and a text color set to black. The CSS file applies the following styles to the paragraph element. Since inline styles have a higher precedence than class, ID, and type selectors, the black background color and white text color will not be applied to that paragraph. To override those inline styles, you can use the exclamation mark important keyword, like this. This keyword is used after the CSS value and before the semicolon. Now the paragraph will have those black and white colors applied because the inline styles are being overridden with the use of the exclamation mark important keyword. This keyword in CSS is used to give a style rule the highest priority, effectively overriding other declarations, including those with higher specificity and inline styles. However, the exclamation mark important keyword does not change the specificity of the CSS selector itself. It simply ensures that the rule is applied, even if there are other conflicting rules with higher specificity. Another appropriate use for this keyword is to override styles from third-party libraries or frameworks when you do not have control over the original CSS. However, overusing this keyword can lead to difficulties in maintaining and debugging your CSS, as it breaks the natural cascading of styles and can lead to unintended consequences. So, it is best to use the exclamation mark important keyword sparingly. How does the cascade algorithm work at a high level? The cascade algorithm is the process the browser uses to decide which CSS rules to apply when there are multiple styles targeting the same element. It ensures that the most appropriate styles are used based on a set of well-defined rules. The process begins with relevance. The browser first filters all the CSS rules to find those that actually apply to the element in question. This includes matching selectors and considering media queries that might be in effect. A media query is a CSS technique used to apply styles based on the characteristics of the device or viewport, such as its width, height, or orientation. You will learn more about media queries in future lecture videos. Next, the algorithm considers origin and importance. CSS can come from different sources: the browser's default styles, user agent, styles set by the user, and styles written by the author, you. Following the considerations of origin, the algorithm then evaluates the importance of each rule, giving priority to rules marked with the !important keyword, which overrides other rules, regardless of their source. After filtering by origin and importance, the algorithm looks at specificity. When two rules from the same origin and importance level apply, the rule with a higher specificity will be applied. Specificity is a measure of how targeted a selector is, with more specific selectors taking precedence over more general ones. Finally, if everything else is equal, the order of appearance comes into play. When two rules have the same specificity, the one that appears last in the CSS will be applied. This is why the order in which you write your styles can sometimes affect the outcome. Let's take a look at an example. Here we have a single paragraph element on the page. Inside the CSS, we have two rules, each targeting the paragraph element. The first rule sets all paragraph elements to the text color of blue, while the second rule sets all paragraph elements to the text color of green. So which color will be applied? The color green will be applied to the paragraph elements, as you can see in the screenshot. By considering relevance, origin, and importance, specificity, scope, and order of appearance, the cascade algorithm ensures that your CSS behaves predictably, allowing you to design more complex and nuanced web pages. How does inheritance work with CSS at a high level? Inheritance is a key concept in CSS that determines how styles are passed down from parent elements to their child elements. Just like in the real world, where children often inherit traits from their parents, in CSS, certain properties can be inherited by child elements from their parent elements. This allows for a more efficient way to apply consistent styling across an entire document. In CSS, not all properties are inherited by default. For example, properties like color, font family, and line height are inherited. This means that if you set the text color on a parent element, all of its child elements will inherit that color, unless you specifically override it. The text color on a parent are inherited. This means that if you set the text color on a parent element, all of its child elements will inherit that color, unless you specifically override it. For instance, consider the following example where a parent div element has its color set using an inline style, and the child p element inherits that color. In this case, both the parent div and the child p will display their text in blue because the color is inherited. On the other hand, properties like margin, padding, border, and background are not inherited by default. If you want a child element to inherit these styles, you need to explicitly set them, either directly on the child element or by using the inherit keyword. The inherit keyword can be used to force inheritance of a property from a parent element, even if that property is not normally inherited. For example, if you want a specific child element to have the same padding as its parent, you can set padding inherit on the child element. In this case, the child p element will inherit the 20 pixels of padding from its parent div element. Here's what the result looks like rendered on the page. Inheritance is especially helpful for maintaining consistency and reducing redundancy in your style sheets. Instead of writing the same style rule for multiple elements, you can define it once on a parent element, and the child elements will inherit it. This can make your CSS more concise and easier to manage. However, it's important to remember that inheritance only works in one direction, from parent to child. If you override a style on a child element, it won't affect the parent element.